Okay, this will be basically probably the final video in the part series for the multiplexer. And basically, in this video, I've been trying to go over everything I've been doing kind of in the winter for the riding season. And just to kind of show you my test setup here that I have for the multiplexer project. I've got a test board hooked up here. This is the relay that I initially installed that came with the light kit. And what I've done is I basically just put some spade adapters so I can flip back and forth. This is pretty much ready to go. This is basically the enclosure. The enclosure will come down and mount right here on the roll bar with some tie straps or some pipe clamps. Really rugged enclosure. I mean, you can't really break it. As far as like dust and dirt, this whole board has basically been encapsulated in conformal coating. I don't know if you can see it in the video, but it's a little bit shiny. There's no conductive surfaces on it. This particular board, I basically dunked it down in a mud-filled bucket and basically let it run for a few days just to make sure that there's no issues, and cleaned it back off. But this is it actually hooked up, and just to kind of give you an idea, there's a lot of spare wires here. These red wires are outputs that I'm not currently using, and then there's a ribbon cable that comes out and goes up. Right now I'm only using one of those outputs in this test. There's 3 more available. So in this small package, basically we're controlling 4 inputs and outputs. This is just maybe this is about the size of 2 relays, but it can actually do the job of 4 plus all the extra stuff. The main things that I really like about using this method, and I've done a lot of testing with it, but basically this is monitoring for any kind of fault. Now, faults being like an open circuit. In other words, there's no load when a switch is turned on. That's going to cause a fault condition and cause you to reset. The way that I've actually got the code written on here, the reset occurs basically either when you power the device down. Right now I've actually got this tied. There's a resistor on this board that ties the 12 volts to the feed side. But let's see if I can get it turned around here. This pad right here, basically you can remove a resistor and you can solder a wire onto this pad and actually hook that directly to the accessory. That way this board's only actually running when the accessory power is on. Right now this board's running all the time, and I've got it tied in the main 12 volt supply, and I've got the resistor in place. Just to kind of show you how it's going to work, let me see if I can get it positioned here where we can see both things happen. So I've got the LED light switch here, and as you can see it's not turning on because I have an accessory feed to this switch. So when I turn on this switch, it'll only supply 12 volts to the input if there is accessory voltage. Now that we have accessory voltage, the light bar turns on and off. As you can see, it's pretty much instantaneous. The big difference is I don't know if you'll be able to hear it on camera, there's no relay clicking. That's one of the nice things about solid state. So there's no moving parts other than this mechanical switch. And there's nothing to say, since we have low current and we're using a relay, we could use any switch we wanted to use in the panel. So just kind of, I'm going to try to position the camera where I can still get everything in the shot. I'll reach around here, and if you watch the board, the LED, one of the LEDs is going to turn on when I turn on this switch, and the light bar turns on. Like I say, this light bar is pulling right at 18 amps. And I'll reach around, and the FET to actually powering that's right where my finger's at. I did silk screen on some caution, showing that it could be hot. Reality is this board will actually support 34 amp loads. That's pretty much the limitation, given that you may be running this out in the desert or something. But here in my shop, running a full load, I can't feel any heat difference. So the RDS is really important. This is going to be really reliable. Banging around vibration, the conformal coating, and the solder process are really important, that nothing breaks off. I chose this particular style of case just so I can actually run that full load, because this is basically going to be about as exposed to air as you can get it. And I think I can see there in the camera, you can kind of see the gloss on the board. That's the conformal coating that's protecting the circuit. But this is going to be really durable. This will definitely last longer than this relay. It's going to take up less space for a lot more inputs and outputs. I don't have all the rock lights mounted yet, but one of these will be for the rock lights. There'll be another one for the reverse light, and I'll also have another one here, which more than likely will go to a radio. And then what I'll do is I'll keep adding boards. I'll probably add a board to the rear section of the RZR to turn on some stuff back there. But this is basically it, and it kind of gives you an idea of what's actually happening here. The wiring will actually get a little bit simpler than this. This is kind of a there's a lot of stuff going on here, mainly because I did do the relay, and there's more wires that you need, and they're relatively large, and they don't have to be here. I don't know if you can see the gauge wire of these inputs, but they're going to be really small. This is overkill for the inputs, obviously, but that is the inputs. Code-wise, what I've done, let me see if I can get a connection here, but basically there's more outputs. I'm just going to turn on another output. I think you can maybe see the LED. Basically what I'm doing is I'm tying one of the inputs to 12 volt. Just going to show you that these work as well. And on the finish board, basically what I did is I installed 2 ambers and 2 greens, but in the finish board, more than likely I'm going to go with the ambers. There's the 2 outputs turning on. If I can get it connected here. It's a little bit difficult to do. There we go. Just kind of scraping the wire against the 12 volt. This little mounting solution works really well. The screw heads actually kind of keep it from moving. So when this is strapped down, it's actually really secure. You could put this pretty much anywhere. And another thing that makes it really nice is you can actually stack these. You could do a stack of multiples. So basically every time you add a board, that would be 4 inputs and 4 more outputs. But anyway, I hope you liked this video. Hopefully soon I'll actually have the production units that I'm going to use. I think they're all already accounted for, both in my RZR, and I've got several folks that have already purchased these. But if you have any interest in this or have any ideas, let me know. The next thing I'm going to be going to is this CAN bus, and I think I'm going to stay with the same form factor board. And basically we're going to read the CAN bus and have a direct connection between one of these boards and the CAN bus module, and that's where we're going to start turning on rock lights and other things based off of speed or your gear selection. It should be a lot better solution than what we're having to do now. I think most people are using a little micro switch up on the gear shift, and I can kind of go around that. Again, I've still got everything tore out. I'm probably not going to get to it today, but I'm going to be looking at making a gated shifter for this. But a lot of folks are just putting a micro switch somewhere in this area to detect reverse. And This has been running, you know, the whole time. Just another test, just filling here. That's directly below that FET. The output that we're looking at is this output 1, which is here, and everything's staying nice and cool. Not a lot of heat stress. This should last longer than this razor will, I'm sure. But anyway, if you have any questions, you know, be sure to shoot me an email. This pretty much closes up. I'm going to try to have, I need to have my razor wrapped up in, you know, the next month or so to go ride. I know a lot of folks right now. I've got a lot of information from folks that are doing the same thing I am, you know, trying to get their razor prepared. And I definitely appreciate, you know, a lot of their videos and stuff. They've been really helpful on seeing what they're doing to prep for the season. Toy hauler wise, really the only thing that I've done is there is one of these in my toy hauler, and the main things I added was all the cargo areas on the Puma Unleashed are not lit, and I basically bought a LED strips, hook this up, and I can actually turn those LED strips on from multiple locations, which is really cool. They're running a little bit different software than these. My plan is to actually make it to where you can either order these with a predefined for predefined application, or possibly I'm thinking about doing a programmer, which would basically connect to the 485 bus and send each module basically its identity, how it's supposed to operate. You know, this particular module, and the way I've got it configured in the razor now, is just if an input's on, it turns on the output. If it's on a 485 bus, it doesn't do anything unless the 485 bus tells it to. In the RV, it's a little bit different. The 4 outputs, basically any of the inputs turn on all 4 outputs, and that makes sense for doing you know, that way you turn on all the cargo areas at once, and you can basically do a momentary switch anywhere in the toy hauler. Right now I've got 3 places that I can turn those on and off, and any press will toggle all of the outputs from any of the inputs. Again, you know, thanks for all the questions folks have asked, and you know, thanks for watching the videos. I really appreciate it.